Alright, welcome back. This is a sample incline plane problem. And for this one, it's kind of some of the standard ones, so that's why I did this as a video, because these are some questions that are, generally asked. So here they are. They are the following. So we have a block that starts at rest at the top. There we go. Just like that. And we have a 30-degree incline. And we know that the box accelerates uniformly down the 2 meters of this whole thing. That's this thing. At the top, and accelerates 2 meters. There we go. So we go 2 meters in 1.5 seconds. So we have to find the acceleration, find the coefficient of friction, find frictional force, find speed. Okay, so we have a bunch of little things we have to do here. So first off, we need to find the magnitude of the acceleration. And we could do that just using kinematics. So I'll just call this A, if you will. What's acceleration? Well, we know it goes a distance of 2 meters. We know it takes 1.5 seconds to do that. We know it starts off at rest. Question is, what is this acceleration? So the thing that comes to mind is delta x equals VIT plus 1/2 AT squared. Now, what we mentioned earlier, and I just mentioned it again, is that we're going to take the axis, or the axes, the following. The x is going to be along the incline, and the y is going to be perpendicular to the incline. That allows that my motion is in one direction, which is a lot simpler than trying to find the components of each acceleration, etc. It would be difficult. So this is the method that I'm using. So with that said, this is in one direction, and since our initial velocity is 0, so that whole term goes away, so what I get is delta x equals 1/2 AT squared. And then what I have next is to find acceleration, which is 2 delta x over t squared is A. I just solved it really quickly right there. Let me put in some numbers. So 2 times 2 divided by 1.5 seconds squared equals acceleration. So 4 basically divided by 1.5 squared. My acceleration is 1.7. I'll do 8 meters per second squared. That's part 1. Alright, now we're going to find the coefficient of friction. So now we're going to do some forces. So actually I'm just going to move this out of the way just for the time being. And I'm going to draw a free body diagram. So here we go. We have friction acting down, straight down. The normal force acting straight up, like that. Now we're not pushing it or anything like that, so that means that this is going to be the frictional force. Now there's no force applied because we're not pushing it. We're not pulling it, there's no tension. So these are the 3 forces acting on our system, just like that. Okay, so with that said, we need to find the frictional force, and as you can see, one tactic is to try to find the force normal, which is I think where we're going to be going. Find force, friction, force normal by looking at the sum of the forces in the x, and then looking at the sum of the forces in the y. So and it says find mu. So mu is going to be, if you see, force friction divided by force normal. So I need to find both of these to find that. And I get both of those from here and here. I get force friction from here and force normal from here. So watch what happens. So I'm going to take this and just redraw it so that it looks flat. Like this. Because if you look at it, when it looks flat, it looks a little different, right? Looks normal, if you will. Basically, I rotated this down. But what happens is I make gravity do something weird, right? It comes at an angle. So if you look here, like that, that angle here is 30 degrees. Because that's how much I had to rotate this to actually come back down so that it's flat. So now I'm going to do my analysis this way. So my x equation looks like the following. It's going to be, now you can see that I have a piece here, FGX, and then I have a piece here, FGY. So friction is backwards. I'm going to call going down the incline positive. That's what I'm going to call positive. This way it's a little easier to work with, which makes my friction negative. With that said, I have my FGX right here minus force friction equals MA. This thing is accelerating. There's no keywords like constant motion, so this thing will actually go down the incline. Let me write the equation for y and then we'll solve them. So for the y, I have force, oops, that should be force normal, and then this is force gravity in the y. Let me fix that as force normal. Apologize. There you go. So force normal's up, minus the force of gravity in the y equals 0 in this case. In other words, this thing's not moving up or down in this or accelerating in that motion. So let's keep going. Actually, I want to do this one. I guess it doesn't really matter. But remember that I have this, I have the mass, which is 3 kilograms. I don't have this, but I can find it, and then I can find the G component. Now be careful, because look at GX, FGX. This is opposite, so this is actually going to be a sine. And then for the similar reason, the FGY is actually going to be a cosine. And then generally, I'm just going to do this. We write FGX as mg sine of the angle. And then FGY mg cosine of the angle. Remembering that FG is mg. Alright, I'm going to do this symbolically. So I'm actually going to take my work over here and find, so to do this, 3 right equations. For, I'm going to find force friction first. So if I do this out, you'll see that I get, if I move the FGY over, I get negative force friction equals MA minus FGX. Or in other words, if I flip the signs, I get FGX. This is a G, not a Y, minus MA. Like that. Force normal, if I move that over, you'll find is actually kind of nice. It's just FGY. And force normal will then be mg cosine of our angle. Just like that. So in essence, what we have is, now you could solve for the numbers here, solve for the numbers in, and then plug it in. I'm just going to do it as a algebraic expression just to show you. So what we get is mg, this is sine of the angle, minus ma. So notice I've plugged this in for force friction, and then I get mg sine of the angle, cosine. And then we set that equal to mu. That's our force normal. Now the reason why I did it like this, by the way, is to show you that we have mass in common in every term. So that actually goes away. So mass is here, here, and here. So again, that's the reason why I did it like this. Now don't cancel g's out because you still have an a here. But the final answer is going to be g sine of the angle minus a over g cosine of the angle equals mu. Now, I think even if you look it up in Wikipedia, they actually have this exact equation. And this is basically how you get it. So let me just plug in the numbers just to get those numbers. So I get g 9.81 sine 30 minus our acceleration from before, which was, what was it? 1.78. Okay. 1.78, like that. And then this is g cosine, like that. 9.81 times sine 30 minus 1.78 divided by 9.81 divided by cosine 30. And our answer is 0.36. 37 if you round. Well, let's do that. There we go. That's good news because it seems reasonable because it's between 0 and 1. So that's a good way you could check your answer. So I'm going to stop the video here because I'm going to need some more time to do the well, actually we found the frictional force. Let me just find that really quick. Because technically we found friction already, which is this part right here. So why don't we do that? And that's actually, this is part B. Part C, if you will, is find force friction. And we made a claim that it's going to be this, FGX minus MA. So when we do that, it's going to be mg sine of the angle minus MA. So when you have two terms in common, you could pull it out. So this can be written like this. And then now I can plug in my numbers. You don't have to do it like this in terms of pulling out that, but the good news is you don't have to do the mass twice. You do it only once. That's why I like to do it like this. I'm skipping all the units, as you can see. I'm doing that just to go faster. So our frictional force, when you solve for this, is 9.375 newtons, like that. And there you have it. Actually, I might be able to solve. Why not? Find its speed after the 2-meter slide. This is more kinematics. So technically, for part D, I would just use this equation. Because we are treating the incline as one direction, so we can use this. And in fact, this is nice and easy because that goes away. So we have final speed is equal to 2 times the acceleration, which we calculated in part 1, times the change in x, which is, let's just write the number there, 2 meters. So 2 times 1.78 times 2. Now don't forget to square root to get v by itself. Now I have the final velocity 2.67 meters per second. Just like that. And there you have it, all of our answers for all of the incline type of problems. So the biggest thing with this is to make sure that you can draw this and then get to here. If you could do that, then you're golden. This is like the hardest part right here. But I believe after a couple tries, you should be an expert. So, after solving a few problems and, going over it, it will click, okay? Alright, I'll see you in the next video.